Okay, I would like to teach you now a trick. I didn't make up the trick. It is an interesting way, it's sometimes a shortcut, how to find the expected value of a random variable. The trick works in some cases. So to start this, to explain how this trick works, we'll start like this. We will take the simple expression of finding an expected value, and then we'll fool around with it until we get a different expression. So let's see how we start. Okay, we start off with this expression. You see in the top of the line, it says, the first top line, it says x times fx from b to 0. Fx can be any function, any legitimate function that keeps that has the qualities of a PDF, and the b to 0 is the boundaries. Let's use an example. Let's say everybody who studies for the exam P knows that there is the famous 2x. It goes from 0 to 1, and fx is 2x. I'm writing the picture. We should see. I'm sure everybody recognizes this PDF. It goes from 0 to 1. Fx is equal to 2x. So we know that the total area of this is 1, because it's 1 times 2 times a half is 1. So fx is 2x. So let's write it down. How do you find? Everybody knows that from the textbooks. How do you find the expected value? You make x times fx, and you integrate it from b. B is the boundary, so that's here. It's 1 to 0, and you fill in x times 2x dx from 1 to 0. I'll show you the paper in a minute. 2x squared. This is I'm going through each step separately. As you see, it's x fx, then it goes x times 2x, so it's 2x squared, 1 to 0. Now, to integrate that, we know it's x cubed times 2/3, and that is 2/3. That's the final expected value of this thing. Bring it close to the screen, you can see it. It gets 2x cubed over 3, and then you evaluate from 1 to 0, so it's 2/3. Now, it's quite simple, this one, so we really don't need any shortcuts, any tricks. But let me do something funny here, and let's see how to work around with this thing. Okay, so first of all, we'll rewrite this. Instead of making 1 to 0 x fx, I'll do something. It'll be the exact same thing. It will sound weird, what am I accomplishing, but you'll see after manipulating some stuff, something funny will emerge. Okay, the way we'll do it now is like this. I'll write down just plain fx, not x times fx, and we'll make dy dx, and then x 0. Take a look at this top line. What I did here, I made a double integral from this. It starts with fx, then that goes from x to 0, and then you integrate it. Now this thing here, just if you work it out, so the fx dy is just simply as we know, when you integrate in respect to y, there's only an x involved there, so it just turns out to be fx times y. And then you do this from x to 0, so it is fx times x, and then you do again from 1 to 0 dx. So it's basically, right now, what I did, first I took the first integral, and in respect to y, so since there's only an x involved here, so this turns out to be fx times y, and then you make it fx times x minus fx times 0, so it's x times fx. Then you do that from 1 to 0 with dx. So basically, looks like I simply did some nonsense here, because I just added this stupid, why do I have to write it in such a weird way? I just made things more complicated, right? Instead of writing simply x times fx, I just added another integral, make double integration that just messes you up all the way, and that's what I did. I just made things for no good reason. I just added another integral, and anyway ends up with the same, what is the accomplishment of making double integral when it's not necessary. So here's where it comes the fun part. This is just like seems stupid, silly. What I'll do now is I'll make the change of the order. This is a very important concept. You know, every double integral can be done two ways. It can be done the y first and then the x first and then the y. And sometimes, if you do it upside down, it gets easier or harder. So let's take this top expression here. I'm making it into a box. You should see this top expression. I want to manipulate it. I want to use this top expression and get first the y and then the x. So first of all, what I'll do is I'll make the textbook tell you to do. First, you find out the area that you're working with. So in this case, you're working from double integral. You're working with the x is from 1 to 0, and the y is from x to 0. So I'll make you a picture. You should see what we're talking here. Look at this bottom thing. You see here the x goes from 1 to 0, the y goes from x to 0. That's exactly what this top thing is telling us to do, right? So we'll just make a picture to see what is exactly happening here. That is what you're doing. You're first integrating from x to 0, and then you're integrating from 1 to 0. We'll rewrite this formula. We'll do the outer thing will be a dy, and the inner one will be a dx, and again the y is also going, you see from the picture, is going from 1 to 0. The x, however, is running from okay, in this picture, let's see what's happening here. The x is 1 to 0, the y is from x to 0. Now we'll convert it. We'll make the y the outer one. So y again is from 1 to 0. X is from 1 to y. And again, we use the same thing, fx. I'll show you what I did. Take a look at the bottom picture, and as you see, I just put the y, the dy outside, and the dx inside. And now the boundaries change, because the y goes from 1 to 0, but the x goes from 1 to y. Make sure you understand why this is. And the fx is the same. Basically what I did is, I put the y outside and the x inside. That's a common thing to do. So take a look again at the whole page in one shot. The first one was taking the x outside and the y inside. The second one is doing the integration first with the x and then with the y. That's the idea of this last line. Now, we're not done yet, we're almost done. Once we have this, it's the same thing, it should give us the same result. So this should also give us the results of the expected value of x. Now, we know that fx dx is something like this. That is we should recognize that. That's called the capital F of x. And if it goes from 1 to y, it would mean that we're working here our way the opposite of a fx. What do I mean by that? It means working your way. We know that a fx is a function that goes all the way from the x till 0. We can define something the opposite of fx. It means all the way from the highest till the x, not from x to the lowest. Is the highest point till you reach that. So in this case, take a look at the bottom. If you take a look at the bottom, I wrote fx, the integral. So I'm sorry for the interruption here. So what we see here is that we can take this thing and get it into such a form, and I'll call that fx. Actually, I'll call it fy, and I'll call it sy, because it's not. What is sy? Sy means the opposite of what we're used to think about f. We know that f means taking all the values up to x. That's what fx symbolizes in this, in the context of a probability function. It's called a CDF. Let's use something the opposite definition. Everything's from the top, from the infinite till you reach the y. So actually here 1 is the highest point and y is the lowest. So what you're doing is you're creating a new kind of function that's defined by 1 minus fx, that's sy. That function, you simply, that is the integral of this. The integral of this bottom thing of fx 1 to y is like saying sy, because you in reality you are integrating the fx and you're taking it from 1, that's the highest point that it reaches, that x goes, and you're taking it all the way till y. So this is the sy. Now, once you have that, once we define this function that's called sy, we just take all the y values from 1 to 0, and we do it. We take them all from the highest point till 0. So we take all the ones from y is 1, a half, whatever it is, from 1 to 0, and we take the sy. That means we go, the point where it stops should be 1, 3/4, a half, a quarter. That's what the sy is. We're evaluating from y. I'll make some lines to understand what we're doing here. I'm taking, you see here on the top, you can see what I did. You're taking all these columns. They show you're taking the y's all the way. You're starting with y, from y is 1 to 0.9, then from 1 to 0.8, then from 1 to 0.7, and from 1 to 0. That's the sy that you're doing in the last evaluation. You're taking sy dy from 1 to 0. That's what I wrote here. What you're doing here is you're taking each y. Y means where it ends, from 1 till what? Till 0.9, till. So all these sy's, we add them together, and that is the left integral. Now, let's incorporate this whole thing in this case, in this formula we use now. So here the fx is 2x dx is the integral of that. We know that the integral of 2x is x squared. So we write x squared, we do it from 1 to y. So it's 1 minus y squared. That's how it gets x squared. So it's 1 squared minus y squared. Finally, we take the integral of this from 1 to 0, 1 minus y squared dy. So we know that this gets into y minus y cubed over 3. From 1 to 0 is 1 minus a third. It's 2/3. Minus a third is 2/3. So this is the trick, a new trick, how to find the expected value of x. And sometimes it's easier, sometimes it makes it harder, but in the yesterday's situation, it actually gets easier because we did something. If you remember from yesterday, the way we started off is that we had a uniform, x is uniform between 0 and 1. We know the PDF of x is simply 1. Then we made something like y is equal to x to the negative 0.8. Just want to refresh you from yesterday's lecture. And we were wishing to find the expected value of y. So the first thing is, if you wish to find first of all the CDF of y, Now, in some cases it's easier because the rule is to find the CDF of y, you simply use the CDF of x when you plug in the inverse. So here the CDF of x is simply x, and you plug in the x, the inverse of this. So the inverse of this would be, so we had yesterday, the inverse is y negative 1 over 0.8. That's the inverse. So that's the CDF. Y negative. The rule by CDF is sometimes easier than PDF because you simply write down the CDF of the original thing, and whenever you see the x, you just plug in the inverse. That is the rule, how to invert from the x to the y. So here you simply have an x, so in that x you plug in this whole thing, this expression, y minus 1 over 0.8. Now, this is the CDF, but you need to go, as I said, you need to take 1 minus that, 1 minus y negative 1 over 0.8, and you take the integral of it. So this gets into y the integral of this negative is y minus no, I think I gotta do it here. It doesn't work for some reason, and I still don't know why it doesn't work. So let's see why it doesn't work. I take first Okay, I think I gotta see why it doesn't work, so I'll do that in the next video. Thank you for listening.